Here I'm going to give a few tips on using MATLAB. One of the things when you're writing programs is you usually spend a lot more time reading than writing. If this is usually how MATLAB starts out, similar setup, you wouldn't have this many files over here, but a good place to start if you're just getting started is, of course, getting started. Basic stuff about MATLAB in it and variables and things to get started with. So the desktop basics, again, will do that. And again, if you did your work, you probably already got that. Another thing you can do is hit the F1 key for questions or this question mark. In this case, it takes you to another place, MATLAB documentation, where you can drill down into MATLAB a little bit, and it will again give you, again, this is reference material now. You already did the getting started, but now we're into the language fundamentals and more important things. Okay, but basically, again, like I said, you're typically wanting, there's thousands and thousands of commands in MATLAB, and a lot of your time is spent figuring out which command to use. So one way to find out information on a command is within the command window, just type help clear. And you hit enter and you get output here that's quite extensive and just tells you what clear does. Clear with nothing just removes the variables from the workspace. Now if you want something a little bit more detailed, of course you can click this reference page for clear, but if you prefer, you can do a doc, and let's do doc to CLC and see what that does. CLC, and it tells you clear command window, clears all the text from the command window, resulting in a clear screen. Another thing you can do, again, if you know the command name, or at least the first few letters of the command name, is CL. And again, it gives you suggestions there for other possible commands. Clear. Now notice, you can see here functions. There are 4 clear commands. It's one of the problems with MATLAB is it's got so many commands. There are multiple clear commands. We're not using Simulink here, so the only one we're really interested in is the third one, MATLAB clear. Remove items from workspace, clearing up system memory. So it would take you then to the documentation page for clear. Boom, search clear. Remove items from workspace, freeing up system memory, and several of the other clear commands. And there's actually more now. Okay, another thing you want to watch, in this case I've got my letters bigger, so we can set in the home ribbon, we can set the preferences, and some of the things you can set are the font sizes and how various other things look, just to make it more comfortable for you. But the layout is one of the main things, and I like to have the command history docked. So it's docked here. It shows what commands we've entered so far. and select a command and hit Shift and arrow key to select multiple and delete to clear stuff out of the command history. Okay, we've noticed a little thing maybe, if you don't, that's really helpful as far as finding documentation is this little FX in the command window, or you can do Shift F1. If we click this, we get a window pops up like this, and I've clicked the Matlab to open that menu a little bit, drill down a little bit, and we can do language fundamentals, and we'll look at operators and elementary operations and arithmetic, and look at plus. Now that we're actually down to a command, we get a little bit of help. Matlab functions adds arrays A and B and returns the result in C. So you can either do A plus B or plus AB. More help brings up the documentation. It shows the syntax and the arrays. Again, this is just an alternate way. Now, you can add a number, a scalar value to an array, in which case the answer will be the size of the array, but it adds that scalar value to every element. And we can see what happens when we add two arrays. They need to be the same size. And adding vectors, and you can see for examples. It's fairly useful to look through the basic MATLAB stuff. Language fundamentals. But you can look at various other things too. I'm going to leave it like this. We'll use that later in a little bit. Okay, I'm ready to try writing a program. I want to write a program, so I'll do my clear console. I don't have any variables in the workspace to show, so we don't need that. And I delete the single command in here so I can keep my commands. Okay, what I want to do is have 2 points. Let's just make them a equals -3, say 2. So I'm making this an array with 2 elements. So there's the x value and the y value. A semicolon, and I can enter another point B. I'll make it be a 3 and a 6. So I've got a line that's sloping upward from 2 to 6, -3. And I'm going to define my point now. C, say 1, -1. And another semicolon to keep the output out. Let's make that a capital C. Okay, those are my points. We see they're listed here with their values in the workspace. So we didn't really need to print them out here. Now I want a parameter. So I say T equals len space, and if I hit my F1 key while I'm here, it should bring up the documentation for len space. And we could go through and read that. But I know what I need. I want I want it to be an array that starts at 0 and ends at 1. And let's put 51. Let's make it 51 points. And I definitely don't want to see that. Now we see that T here is a 1 by 51 array. If I double click this T, it will show me I've got one row, and it showed me all the values. The 51 is 1. Okay, I want to make a line. To do a line that goes from A to B, I'm going to multiply 1 minus T, and I'm going to use the dot times operator. A plus T dot times B. And I try to do that, and it doesn't work. So it gives me an error message. Okay, matrix dimensions must not be. I wanted to just multiply and ended up with a 2 by 51 or 51 by 2 matrix. So let me try something different. I'll still make it line. Make it an array, but 1 minus T. But now I'll just do A1 plus T times B1. Now I don't need to use a dot because A1 and B1 are scalars. And I'll make another row that'll be the same thing. 1 minus T times A2 plus T times B2. Now the first row has the X values, and the second row has the Y values of the line. So it's 2 by 51. I decided I like my line to have be the other way. So I use the single quote mark, which is transpose. So if we watch the line in our workspace and I hit the command, we see it went from a 2 by 51 to a 51 by 2. It just means each row now has the X value and the Y value. And I forgot to hit the parentheses, so we get the whole line out. Okay. Now we want the distance between each one of those points. D squared, I'll call it the square of the distance between those points. And that will be the lines, all of the X values. And the first column, minus the X value squared plus line, the second column, minus C2, and close that and square it. And I hit enter, and oh, I've got a mistake here. What's wrong? Invalid expression, indexing variables, use parentheses, otherwise check for mismatch. Oh, I forgot the parentheses before the second difference in the Y locations. So I can just use my up arrow key and then left arrow key and get over here and add my parentheses and hit it again. Oh, I forgot something else. The exponents need to be dotted. Since we're doing an array, we want dots. So again, I'll go up and we want a dot, use dot. Again, that's what it says here, to use this dot operator. Now, I've got the squared distance between each one of those points on the line and my C point. I want to find the min value. So I will bring up this category thing again and say, okay, how am I going to find a min? Min, what is that? Is that a language fundamental? It's dot, pre-processing data, descriptive statistics. Min is a statistics. Ah, here we go. We've got a min. So I can hit the min, and I see there's a lot of variations of min. I really want the index. So I want the index of the min. So is there a command to just find the index? And I look around and I don't see anything, any command to find the index. So let's look at this min command here, and we'll go for more help. So we see all kinds of variations of this minimum or min command. And we go down and read the descriptions, and it tells min, you know, if it's a vector, it's just, if it's a matrix, it's the row, multidimensional, the first size greater than 1, etc. Min returns, min. Okay, here's a different one. Min, I've got a bracket mi on the left side of the equals sign. It says also returns the index. All right, that's what I wanted, was that the index into the operating corresponds to the minimum value of A. Again, I'm going through this relatively quickly just to show actually how you're doing it. Okay, so I want D min and I min. Again, D min is actually squared. So min and D squared. And we see we got two new variables. They're over here, D min and I min is 13. So if I want to look at the actual distance, minimum distance, I need, though, to square root it. And it's just a scalar, so it doesn't matter. The distance is 4.7 inches, or 4.715. And to find the actual point, I'll use this I min, the index, and I want both columns. So this should give me the point that's closest to the point C. Okay, I've done a lot here, and I've worked this command, these things in the command window, but it's really handy to make these a script. So I click on the first line here in the history window and scroll down, and then I'll right click and see it says create script. So I'll create a script. Now we have a new window, a script, editor. It says editor. And you'll notice here on the right side there are several little dashes. The gray dashes, the A is highlighted. So anywhere there's an A in the script, you'll see a gray dash. If we go over to the C, again, anywhere there's a C in the script, you'll see a gray dash. We don't want any of that. You'll also notice orange and a red line here. These indicate some kind of errors. Of course, as you might guess, the redder it is, the more serious the error is. So we see here there's a parse error. There's an extra close parentheses. So we see here the extra close parentheses is even highlighted here that this is a mistake. We remember that was a mistake when we did it. We also have these red dashes in the command history where we had errors. So we can delete this line and it's only an orange error here. It says the value may not be used because we defined d squared here, and on the next line we redefined it. So this first d squared is not used. So again, from the red dash on our history, we know we don't want that. And we remember when we ran this line, it printed it out. Notice the equal sign is highlighted and it's got an orange bar here, and it says there's no terminate. When you're running a script, they recommend terminating everything with a semicolon. You don't really need to do that, and you'll get the answers printed out in the command window if you don't. Okay, I've still got one here. It probably says line may not be used. We remember this was an error here, so we'll delete that also. Now we have our script set up. We've got this indicated error that we should terminate it with a semicolon, but I really want it to write out my answer dmin. And I might even give this a name or a value. It's really the point on the line. Point equals the line. So we've got a point on the line. Okay, if we run this just by clicking the run button up here, we want to, okay, now try running it. And we'll see we got an output here. We've got the dmin is 4.715 and our point is the same point we had before. We've got these orange marks here. Again, it doesn't like using the standard output by not using the semicolon. So we need another form of output. So I'll put a semicolon here and see if we can get a better form of output. So I'll go to the FX column here, and under MATLAB, data import and analysis, low-level file I/O, we finally get something useful. What I'm looking to use is fprintf. Fprintf will print the function out. But let's go to more help. I move too fast and go off of stuff. Okay, and we've got two main syntax here. One's got a file ID. When we print down, we'll see we're not really writing to a file, but we're writing to the console. So we don't want the file ID. So we want the console. And we can go on down, and there's a lot of stuff to read here about printing. And make sure you check out See Also, because there's other ways of outputting data, mainly this DISP. Or fwrite will write binary data. So anyway, so I know how to use this, so I'm going to write the commands here. Printf, and what basically the format spec is just a string. So you start by writing, minimum distance between point and line is. Now when you want to output a number, you need essentially the format spec, which starts with a %, and I usually start with a 0.3f. So that's a floating point number and with 3 decimal places. And then do a \n to end the line. Now I need to give it the number to output there, so I just do dmin, close, and a semicolon, and we have that line. So then I'll output the distance, but I also want the actual point on the line, so location on the line. So you just start location on the line is, and I'll do a %.3f, and whatever else you type after the f will actually appear there, so I'll do another %.3f to do the y value. And a new line at the end. Now I need to supply 2 values, but I can really notice that my point has 2 values in it, so I can just do my point. And that'll be the end of that printf statement. Now when I run the script again, I get something a little better as far as output goes, the minimum distance between points and the location on the line. So that looks much better. We'll notice that this line is a little bit long, so outside of the quotation marks, I'll put 3 dots and a return. That is MATLAB's way of doing a continuation line. Now what's missing from this script is something we need all the time, and that is comments. So generally what you do is 2 % and say what it is, what you have here. Script to find the distance from a line to a point, So that's what this script does. Now, for this course, we'll have always 3 sections. In this case, I'll call it the given, which is the information you were given to run the problem. That is the input to the problem. And first we have, of course, 2 points on the line. Then I'll put another return here so I can define the other point. Define other point. that is the point that you want to find the distance to. So everything that's input to the script, so to speak, you put in this given section. And you have a solution, or I like to actually call it calculations section, that actually shows what you're calculating. And here we've got a new variable, t. So anytime a new variable appears, it's best to give it a comment to define it. And I like to leave a fair amount of space there. You can line up the percents for your comments to make it a little bit easier to read. So t is a parameter for the line. Don't need to comment everything, but it's important to comment where new things are. Now I'm going to use another double percent sign here to make a new section. The advantage is you can run sections separately. You'll see now we have a run section, so we can run the first section and then the next section. But I'll just call that, d squared is the distance squared. We did squared again because it was easier. It's easier to do squared. We don't have to take the square root for every point on the line. We really only need to take it for our point of interest. Finally, after all the calculations are done, in here we have an answers section that prints out the answers. So we'll take this section out right now. We don't need it as a section for this code, and we can again run it and get the same thing.